Okay, so we want to graph other trigonometric functions other than sine and cosine. So we're going to start with the tangent function. So we're going to just make a table of values. So this will be my x, and then we're going to be graphing tangent of x. So we're going to start at 0. Yeah, okay, well, we'll start at 0. and we'll see what happens. So the tangent of 0 is 0. And so the decimal approximation is still 0. Okay, so we're going to go ahead and start on the first quadrant. So we'll say pi over 6. And the tangent of pi over 6 is the square root of 3 over 3. And then I'll have to get a calculator to figure out the decimal approximation for that. So the square root of 3 divided by, oops, got a weird thing going. Square root of 3 divided by 3. And I'm getting it's 0.6. All right. And then pi over 4. Now you can use your unit circle or whatever chart you have to help you with this. Again, you're going to want to learn them at some point. But the tangent of pi over 4 is 1. So decimal approximation 1. And then pi over 3, the tangent of pi over 3 is the square root of 3. And so I'll have to figure out what that is in a decimal. And it's 1.7. Okay? And then we come to pi over 2. Now pi over 2, remember tangent is, tangent x is equal to y over x, or sine over cosine. And at that point, when you're at pi over 2, well, your x is 0 and your y is 1, right, on the unit circle. So you have 1 over 0 for the tangent, and that's undefined. Okay? When something's undefined, it's going to be a vertical asymptote. So I'll just put asymptote there. Okay, so let's see what happens here. If I draw pi over 2 here, then I'm going to have this vertical asymptote coming right through there. And then if I draw the rest of it, so 0, 0, what I have so far, and then where's pi over 4 would be like in the middle, and then pi over 3 is going to be a little bit here, and the other one's going to be a little bit there. Pi over 6, sorry, pi over 6, and then the pi over 3 on the right. Okay, now let's graph those. So it's going to be at pi over 6, it's going to be, I need another mark here. Let's say that's 1. 0.6 is going to be, yeah, about there maybe. And then at pi over 4, it's going to be up there at 1, and that's a little high. And then at pi over 3, it's going to be 1.7. Let me make another mark. So it's going to be maybe there. And it's going to run toward that asymptote. Okay? Now, what we do when we normally graph a tangent curve, the basic one, we don't keep going around the circle. You can. We can do that. We can make this pi. Well, let's go ahead and do that. Pi. And so what we want to see is kind of that halfway in between. So if we have pi here, what's 3 pi over 4? So you're in the second quadrant now, okay? So now we're over here in the second quadrant at 3 pi over 4. Well, 3 pi over 4 is going to be negative 1, okay? Because your x is going to be negative, okay? And so that one's okay. But then what happens if you come to pi? Well, you're going to be at 0, right? Okay. So we have negative 1 and 0. Now you could do the other special angles in there. It'll give you more points, but I don't know that it'll help you graph it any better than the first section we did. Okay, and so that's going to look like, oh, I didn't do, let's see. Oh, I didn't do the next one, which would be in quadrant 3. So right here, let me go back. That's going to be 5 pi over 4. And that's going to be a positive one because you're going to have a negative x and a negative y. And so it's going to be negative 1 over negative, or negative square root 2 over 2 over negative square root 2 over 2, which is going to be 1. Okay? And then you'll get to the next quadrantial angle over here, but that's going to be the point 0, negative 1, and so the tangent's going to be undefined. Now that's at 3 pi over 2, and this is going to be undefined. So we're going to get another vertical asymptote. Okay, so let's see what that looks like then. I've got pi right here, and then 3 pi over 2, we'll say is right there. 3 pi over 2. Okay, it's probably a little bit bigger than I wanted it to be. Let's graph these points then. Oh, I'm going to need a negative 1, aren't I? Okay. So at 3 pi over 4, it's down here at negative 1. At pi, it was 0. And then at 5 pi over 4, which is going to be halfway in between here, that's going to be back up to positive 1. And then we're going to have a vertical asymptote at 3 pi over 2. So we're going to have another vertical asymptote here. And so we get this curve that's going like this. Something like that. Okay? And this is periodic. It's just going to keep happening that way. So you can do another, quadrant, go to the third quadrant or the fourth quadrant and do that. What we do a lot of times though is to make this more consistent is we go to the other side because it looks like you have like half of the curve here. So we go over here and make that negative pi over 2. And then, you can cut that in half and that would be negative pi over 4. So this would be like the fourth quadrant, but you're just going in the other direction. So we're going like this way. Okay? And negative pi over 2, well, that would be right here. We already did that. That's the same thing as 3 pi over 2. So that's going to be undefined. You're going to get a vertical asymptote. And then if you think about negative pi over 4, that's going to be negative 1 in the fourth quadrant. That's going to be negative 1. And so let's draw this. Vertical asymptote here at negative pi over 2. Yeah, and then let's get the negative 1 in there. I'll have to kind of put it over that 4. And there, it looks more complete. Anyway, that cycle's going to keep going. What I usually try to remember is that for tangent, for one function, I go from negative pi over 2 to pi over 2. It like straddles the y-axis. That's easier for me to remember to do it that way. And remember, this continues. So there's another, another curve thing here and an asymptote and another curve thing and an asymptote. And it goes in both directions. Okay. So this then is the form for a tangent function if we have a stretch factor of a. Okay, so we can still stretch it. It also can be negative, and if a is negative, it's going to reflect about the x-axis. The period. Now, the period for tangent, so this is kind of a big deal. We talked about this at another point, but the period for tangent, the normal period is pi. And so when you're trying to find the period, you're going to take pi, so this is for tangent, pi over the absolute value of b. Okay? So just remember that's how you find the period. Tangent is different than sine and cosine because the period's different. Okay? Now the domain. Well, the domain's a little tricky here. So the domain is all real numbers, except you can't have pi over 2. Every time there's an asymptote, you can't have that. So you can say, I was going to look at the notation here, there's a couple different ways you could do the notation, but we can say the domain is all real numbers. Except, but x cannot equal, now it's going to be pi over 2b, because that's going to affect your period, okay? Plus, and then here's where it gets a little tricky, pi over 2 absolute value of b, k, where k is an integer. It's usually how we say it. Okay. That takes care of all the asymptotes, all that notation there. So it's all real numbers, except you can't have pi over 2. You can't have 3 times pi over 2. You can't have negative pi over 2, okay? So you start with pi over 2, and then you just keep adding these integers of it, okay? Yeah, that's all we want to say on that. Now, if I go back, if I scroll back and look at the range, what do you think the range is? What are the outputs? Well, it's all real numbers, right? This is going off in this direction and this direction, and so the range is going to be negative infinity to infinity. So kind of nice on that. We talked about the asymptotes, okay? So every time there's a vertical asymptote, that's happening at these units of pi. And so you can just recopy this over here, okay? Except I have a little mistake. I thought something looked funny. Okay, so that little 2 is not there. Okay, so you're adding pi over b. Okay, so that's adjusting for the period, and then k. Maybe I can explain this a little. This is kind of a long video, but I'll try to explain a little bit better. Let's say b equals 1. Oops. B equals 1. Then you have pi over 2. Okay, so looking at this for the period, right? Okay. No, for the asymptote. Pi over 2, right? Plus pi times k. Now, if you think of that, you're just adding a pi every time. So here I'm adding 1 pi, and then I'd be adding the next pi, and I could subtract the pi, you know, if I had k being negative 1. And that's what's happening. That's how you're getting all those asymptotes in, okay? So the asymptotes are at x equals pi over 2 plus, well, if it's 1, but if it's not 1, then you have to put the b in, okay? Okay, where k is an integer. Okay, so you'll see it when you graph them.